Young people, welcome back. BMB in the house, taking care of chapter 7, lesson 6. So let's go ahead and start like we always do, guys. The textbook today is hoping that you, with BMB help, will be able to solve problems involving exponential growth, as well as solve problems involving exponential decay. Our title, growth and decay. So, before we get started, guys, we got a major formula and have a second formula you're going to see coming in here today. Just being aware of a lot of plug-in and a lot of words, and growth and decay, exponential growth. So, let's get it. So, handout with very few problems. It's only 6, guys, and as you can see with that 6, it's gone already, but all word problems basically, just a little different, right? So, growth and decay literally is something that comes right in your algebra that is really real world stuff, right? So, that's why we got these word problems. The population of New York City increased from 8,008,278 in 2000 to 8,169,730 in 2005. So we're highlighting important information, of course. The annual rate of population increase for the period was about 0.4%. So, write an equation for the population T years after 2000. So guys, this is what I mean by I would not be able to do this without the correct formula. So pull this off of the World Wide Web, right? And I like it because it makes sense to me. We have, starting off, T for years. Well, and then of course, after 2000. So knowing right now, we want to find the new amount, and of course, it's going to be equal to the principal amount, or the starting amount, original amount, all right? And then of course, parentheses 1 plus, and then the rate, and then of course, there's that T as my exponent for time. So, I'm using P to represent population instead of A for amount. The population is going to be equal to our formula. P times the quantity of 1 plus R, all to the T power. So I'm going to have to find those variables, P, R, and T. But of course, T years, that's why we did it in red, you're good. That's what you want to read in T years, right? So let's go ahead and get some empty parentheses. I think I'll use a bracket instead. And of course, what would we like to start with? Now again, remembering we want to leave it for T, but after 2000, so it tells us in 2000, it was, what was our total, what was our amount, our principal amount, starting amount. Right there in the words, guys, that's why we highlighted the blue, the yellow, the red, the green. And right now, guys, we're going to go ahead and use, let's say we use red, and put the starting amount. The population started at, in 2000, at 8,278. Then plus, now here's the rate, R. Now, the annual rate that we can see in the question right there, right, is about 0.4%. Now we're going to change the percent to a decimal. So we're going to move the decimal to the left 2 places. 25% is 0.25, so 0.4% move 2 places, 0 and 4. Yeah, that's good. 0.004. And of course, for T. And it's okay, guys. T years. We don't know the time, all right? Go ahead and do a little simplification if possible, and do that. But again, that's the final answer. The The reason why, guys, is because write an equation for the population t years after 2000. So the population will be equal to, and that's what we need that formula for. So now, of course, use the equation to predict the population of New York City in 2015. So now we're actually going to come out with a number, right? Will it be 8 million? Will it be 16 million? Will it really decrease and become 3 million, right? So the amount, or the population, is equal to, and now we're using 2015. So, well, basically 2005, now it's closer to 2015, so we'll use that starting amount versus the 2000 population. It increased, so we'll go with the most recent. The time is 10, because from 2005 to 2015, of course, is 10 years, guys. So all of that's my starting amount. You caught the rate, and of course, the 10 is me again referring to, as hopefully I continue to underline and show as I talk about it, right? Talking about the rate, yep, didn't change. And of course, 10 years, mentioned that a second ago. So, I'm doing a little bit of math. And when I say a little bit of math, well, me talking that the 10 came from 2005 to 2015, 10 years of time, right? That's where the time came from. But I absolutely now I'm going to pull out a calculator. Got some big numbers here. Definitely want to make sure I do order of operations. So doing my exponent first, and then multiplying by that big million there. So 8,169,730 times 1.004 to the 10th power, which is 1.040727734. I wonder if that's it, or did I just stop writing it? So again, calculator always, right, and handy. And I'm going to get a big number. Of course, I'm good. The number should increase because my population is increasing. So it looks like it increased from 8.1 million to 8.2 million. And again, guys, I'm not going to say 0.59 because we can't have 0.59 people. But about 8.5 million, 8,502,464, and I'm happy with that, guys. So this was all about, again, plugging into a formula that we brought onto the sheet here. So of course, on your handouts, on your notes, in your book, be aware that those formulas are critical for you to be successful in the concept and skill, right? Concept, skill, you got those two things, you're good. So, number 2, savings. We all like to save a little bit. So now, guys, again, as we talk about exponential growth, your money can grow, right? And again, how I figure out how my money grows, I will use a formula. And you know what? Not that formula. Compound interest, guys. So this is definitely a real world situation. Hopefully at one point you will be looking to have your money make you some money. Going to highlight my 8%. Of course, that's going to be my interest rate. Going to highlight 1,000 because that, of course, is going to be my principal or original amount. And that's all they give me, except when I get to A. If an employee participated in the plan withdraws the balance of the account after 5 years versus somebody else withdraws it out after 35 years. Well, we know who should get more money, but let's figure out the difference. So the amount is equal to P times the quantity of 1 plus R divided by N, parentheses close, all to the NT power. You believe that? NT? Yeah. So this is where, excuse me, don't get caught with words slipping through your comprehension. So 1 plus, I need an R and I need an N. So right here in our, picture, R is interest rate, 8% interest rate. But we can't write it as a percent, we're gonna change that to a decimal as we did before, move the decimal to the left. So it looks like 0.08 is what my rate will be. But I have an N down there. So once I get 0.08, what about the denominator? The The denominator is n, and right here again, the number of times interest is compounded per year. Where do they tell me that at? Where do they tell me that at? How do I know it's 4? Oh, you mean quarterly? You mean 4 times? So that's where it is, guys, quarterly. So if it said, twice a year, you would use 2. Once a year, you use 1. But quarterly is 4 times per year. And you're going to use that 4 again because, as you can see in the formula, it's right there as an exponent as well. And time is 5 because it says 5 years. Now here comes a whole lot of order of operations, guys. Really understanding that do what's inside the parentheses first. After doing your grouping symbols, of course, if you have exponents, which we do have here, have your calculator handy, right? 4 times 5, you know it, to the 20th power. Can you believe that? So if you don't have a calculator and know how to take something to the 20th power, we actually have a place where you can go find it. And it's definitely a skill you want to have and use, especially when you're doing compound interest, growth and decay, exponential functions, all that good stuff, guys. So I use my calculator, and it looks like I got 1.485947396, and I'm just writing everything the calculator said, because I would round, no need to have that big of a number. Went ahead and multiplied, and it looks like you would have made 85.95 cents. So, looking good, guys. Remember, that's only A. That's if it's only for 5 years. Well, again, as we get this mess out of the way, gonna need it still, but can't have it where we're gonna write. 35 years. So, let's take a look at what's gonna change now when I plug in, because again, if an employee participating in the plan withdraws the balance of the account after 35 years, how much will be in the account? Okay, the amount in the account is going to be equal to, we gotta know her starting price, right? Initial. Well, she also, or he also, started with $1,000. And of course, this employee, he, she, or non-binary, your choice, 0.08 divided by 4. And again, the rate didn't change, and the annual, quarterly, 4 times a year, didn't change. The only thing that changed was the 5 to the 35. So again, got a calculator to figure all this out, right? Went ahead and, forgot to put 1 plus. That's okay, I don't call that a mistake. No, not a mistake. I just wrote something incorrect. And like I said, 2 times 3 is 5. Did that in another video. But, all right, guys, so once again, hopefully you got that magic button on the calculator, and it's not a whole big thing for you to take 1 and 2 hundredths to the 140th power. And of course, guys, you would think it's going to be really, really big, but think about it, 1 times 1 times 1 times 1 times 1 times 1 times 1. So it's just a little bit more than 1. It's 1 and 2 hundredths, so as big as it got was 15. And of course, I can multiply 15 times 1,000, but it looks like I'm writing my complete, long, stretched out answer. And of course, when you multiply by 1,000 with that decimal 3 places, you got yourself an answer. A good answer. So, again, guys, we started off with one formula, we went to a second formula. First one was for growth and decay. Second one was for compound interest. They're similar, they look similar, but absolutely understanding when dealing with the interest, how often per year, all right? So housing, Mr. and Mrs. Boyce bought a house for $96,000 in 1995. The real estate broker indicated that houses in the area were appreciating an average annual rate of 7%. If the appreciation remained steady at this rate, what was the value of the Boyce's house in 2009? Well, what do we know? We know 96,000 is a value, and that value represents what? The starting amount. Because they bought the house at that amount, the initial amount. So that, to me, says that's that P, that principal, right? Secondly, I see another number, 7%. I guess I should use that. And what does it say right before it? Rate of 7%. So being I need the rate, R, I'm going to change that 7% to a decimal, and now I'm ready to go. 0.07 is my rate. So this time, guys, starting off, I'm labeling the things that I know, the things that I need before I plug in or even write the formula that we're going to use to solve this. Now, here it says, well, here I'm highlighting 1995 and I'm highlighting 2009 because I need to find the time, all right? What's the amount of time we're talking about here? From 95 to 2009, is that a time of 1 year, 2 years, 3 years, 4 years, 5 years, so on and so on and so on, right? So 95 to 2000 is 5, and then plus another 9 gives me 14, so I'm gonna say 14 years. If the appreciation remains steady at this rate, what was the value of Boyce's house in 2009? So we knew what it was in 95, so 14 years later, that's our time. We're gonna figure it out. So we got it. The new amount that their house will be worth is going to be equal to P times the quantity of 1 plus R all to the T power. So 96,000 times 1 plus 0 and 700ths all to the 14,000. So when I do it that way, guys, I kind of like it because with you labeling the information, plug it in goes very smooth. And hopefully after you plug in with the use of your calculator, it's going to be just as smooth, right? So parentheses first, exponents, and then we're going to multiply 96,000 times 2 and 5, 7, 8, 5, 3, 4. I knew I wasn't going to do it all video, guys. So again, you're going to get a very long decimal. Of course, we've known how to round for quite a long time. So please, especially when dealing with money, no, don't need all them decimals. Don't want to do nuts. Don't want to do nothing. And now that there again has a long decimal, but right in my final answer, we're going to go ahead and make sure the amount, and usually I like to answer in words. The amount the house is worth in 2009 is $247,539.28. All right, feeling good, looking good. Looks like we are going to get this stuff out here so we can move on. As you can see, we got a lot of words on this handout, so let's get some more words up here. Manufacturing. Zeller's Industries bought a piece of weaving equipment for $60. They wish. $60,000. It is expected to depreciate at an average rate of 10% per year. Now, pause. You gotta pause. Because I just underlined a word that you may know or may not know. Before we were talking about a house and how it appreciated. That's a good thing. It means I bought a house, and now that I've lived in the house, and it's been 10 years, the house is worth more now. It's a good thing, right? I bought the house and I lived in it, and 10 years later it's worth more. That's great. That house made some money. Well, that's not everything. Things can lose money. They can depreciate. So in this situation, guys, we're actually going to be losing money. It's going to go down. Again, as I'm about to start again, can you think of anything like that you buy and then once you buy it, it's not worth the same amount? I bet you are figuring some stuff out, all right? So let's get this started again, guys, and just recognize how this is a little different than the one before because it depreciates at an average rate of 10% per year. So every year, it's going to go down 10%. That's not cool, but it's life. So first thing we're going to do is definitely change that 10% to a decimal. So we know that our rate now is 1/10 or 10 hundredths. Next thing I want to go ahead and make sure I got, looks like we're going to take care of, I see. Just getting it ready. Negative because it goes down. It's not going up, remember, it's going to go down every year. Remember before we had plus 3? Well, no. Minus down, guys. It's going down. So, but check it out though. The formula's not on the screen, but now it is. You like that. So we got our P, 60,000. We got 1 plus R. Well, R is not a positive. It's not going to make money. The equipment every year is just going to be worn down, and eventually it's not going to be worth the same amount when they got it. And therefore, how much will it be worth? Is that it? After T years. So, okay, T years. There's the equation. But now, after 6 years, right? So, we do the same thing, recognizing that I can do the 1 plus negative 1/10, which is just going to give me 9/10. And then, of course, 9/10 to the T power. Well, that's still A, y'all. That's the equation simplified. I like it. Simplified it. So now that it's simplified, it makes it that much easier to get B done because I'm ready. So the amount is 60,000 times 9/10, 0 and 9/10 if you like. Oh, yeah, write it all out again. Oh, okay, thank you. 0 and 9/10 to the, and here's, what's our amount of time? 6 years, 6. So again, guys, go ahead and use that calculator, right? 0.9, and then if you haven't found that magic button, somebody will find it for you. 60,000 times 0.5314441, and hit the time button, multiply by 60,000, and we got our answer, guys. 31,886.46. So it's literally going to lose almost half of its value. Welcome to cars, guys. Welcome to cars. So, everything's looking good, feeling good, guys. Remember when we saw this original handout, it was all words. These words aren't bothering us. I'm pulling out our important information, plugging it in, and I'm using our calculator to get our final simplified answers, right? So, let's keep it moving. Finances. Kyle saved $500 from his summer job. Good for him. He plans to spend 10% of his savings each week on various forms of entertainment. Really now? Various forms of entertainment. Xbox, PlayStation, Nintendo. 15 weeks. All right, so I was chatting, missed the last sentence. We're okay. At this rate, how much will Kyle have left after 15 weeks? So, ooh, I like it. Labeling style. The information they gave me, $500. What is it? Starting amount. Information they gave me, 10%. What is it? The rate. And of course, we always know we like to write the rate. Oh, that's important. Because if I'm spending, does that mean I'm adding to what I have? Does that mean I'm subtracting? Yes. So if you're spending, and again, we're talking about a negative. Now 15 weeks as my time, and guys, I believe I'm good to go. The principal is 500. The rate is, and again, converting it to a decimal, so 0.1. But since you're spending it, it can't be a positive rate. It's be a negative rate because you're going down at a certain rate. So subtract, take away. And of course, T equals W. No, TW. T equals 15. So guys, I think I have enough information now to plug in. And now after plugging in, I'm gonna do as I've always. Simplify with minimal mistakes. And the calculator helps minimize those mistakes. So I need my exponent of 15. Good. And now, as I continue 500 times, and this is again, guys, I'm just gonna hit 0.9. Right. If you have a dollar and somebody took 10 cents, you have 90 cents. It ain't hard. So, but 0.9 to the 15th power, just like before, guys, there's a magic button. When you're getting 500 times this magic number used by the magic button, 0.20589113221. No, we went on forever. But again, guys, we're talking money. So when I multiply that value times 500, I get 102. And then what? 94 cents, 95 cents. I can't leave it like that. I want to write it as And even better, guys, I want to answer the question using words. So, BLB, being lazy. I should have answered all these in words, guys, but as you know, some of you guys have been here with me for a while. Our videos can be 30 minutes, and I'm sure you're here to get the best that I got. I can do better by writing. At this rate, how much will Kyle have left after 15 weeks? After 15 weeks, Kyle will have $102.95 left. I guess that's not bad. You gotta do something with your money, right? I just hope he gave some to his mom for groceries. I hope he gave some to his little brother who can't work over summer, so he over there eating on Skittles, not sharing with his little brother. That ain't cool. So I hope Kyle did right by his money and his people. That's just how I feel. Number 6, transportation. Tiffany's mother bought a car for $9,000 5 years ago. Whoa, what kind of car did she get? She wants to sell it to Tiffany based on a 15% annual rate of depreciation. And I would pause right now and just talk about how this mama is trying to, well, you tell me, let's see how much she's gonna sell this car to her mom for. What's 9,000? Well, initial amount. What's 15%? You got it, that's your rate. Depreciation, of course, telling me going down. She can't charge her more money for the car than she paid for it. I don't think so. So, all right, guys. So, bam, gotta love it. Set up, ready to go. We're at the 25-minute mark of this video almost, so let's get it done. Principal is 900. 1 plus R, my rate is, again, negative, this time, 1500s. And of course, the time is 5 years. Using my calculator, and of course, 1 plus a negative 0, 1500s, is going to give you 8500s, thank you. And that's what I need to take to the 5th power. So hopefully you got that calculated, and you're staying with me. Or you're pausing, trying to make sure that you're getting what I'm getting, and that's what I got. Kept that in my calculator, multiplied it by 9,000, and I ended up getting this as a solution. Or an answer, some people say, don't say solution, you didn't solve. Okay, whatever. Solve for A. A is equal to, I guess I didn't like that, $3,993.35. Am I right? Yeah, of course. Unless it's wrong. But, guys, that is what I call a short but long handout, right? So, taking from this, growth and decay, compound interest, it's going to be around for a while, guys. Hope you enjoyed it. Can't wait to see you in the next one.